Welcome to The Explainer. Today, we are looking at what's next for AI. And it's not just about making it bigger or faster. We're talking about a real shift, making AI smarter, way more precise, and a whole lot more efficient.
Okay, so think of today's big AI models, the large language models, as this brilliant but kind of clumsy apprentice. I mean, they can do some absolutely amazing things, right? But they also create subtle bugs, misunderstand details, and wow, do they use a ton of energy.
That's a perfect way to put it. So in this explainer, we're diving into 3 really fascinating new research papers that tackle this exact problem. We're going to look at how we can make AI a better collaborator, a precision designer, and a much more energy-efficient worker. Basically, how we train this apprentice to become a true, refined partner.
All right, let's get into it. Our first big challenge is collaboration. Right now, when we ask an AI to write code, it's pretty much a one-shot deal. You throw a prompt out there and just hope for the best. A paper by Stephen Smith and his team called AI-Assisted Modeling with Domain-Specific Language-Driven AI Interactions really gets to the heart of this.
Yeah, and that is so frustrating. You get something back that's almost what you wanted, but not quite. So what's their big idea to fix this?
Exactly. It's like we're just shouting instructions into the void. So the real question is, how do we stop talking at the AI and start working with it? Turn this one-way monologue into an actual productive dialogue.
Well, the key, it turns out, is to give the AI a language it's completely fluent in, but for one very specific task. This is what's called a domain-specific language, or a DSL. So instead of using broad, ambiguous English, you give it a very constrained vocabulary. It just massively cuts down on errors.
And their new workflow, which we're seeing here, is just brilliant. It's a constant feedback loop. You give a command, the AI writes the code in that special language, and this is the cool part. You instantly see a diagram of what that code does. If it's not quite right, you just tweak your command.
Wait, so you can actually see what the AI is thinking through a diagram while it's coding? That sounds so much more like actual pair programming with a human.
Precisely. It completely changes the game. It goes from a one-shot guess to a real iterative conversation. And for complex systems, that improved control and accuracy is absolutely huge.
Okay, that makes sense. So we've taught our apprentice to collaborate. But what about precision? Because if you ask an AI to draw something really technical, like a logo or a diagram, the results can be, well, they're often more artistic than they are exact.
That's the very next hurdle, and it's tackled in a fantastic paper by Yamei Chen and her team called Symbolic Graphics Programming with Large Language Models. You see, most AI image models think in pixels. It's kind of like painting with a sponge, great for art, terrible for sharp lines. To get the mathematical precision you need for a logo or a schematic, the AI has to learn to think in code, something like a scalable vector graphic, or SVG. And that's the difference between a blurry suggestion and a perfect editable design.
Okay, that makes a ton of sense. But how on earth do you teach an AI to draw with code instead of just splashing pixels on a screen?
So they use this really clever technique called reinforcement learning. The simplest way to think about it is trial and error. The AI tries to generate the SVG code, and then another AI system basically looks at the picture that code makes and gives it a score based on how well it matches the original text prompt.
And this isn't just a one-time thing. This process gets repeated thousands, even millions of times. The model generates code, that code gets rendered into an image, a powerful vision model scores how well it did, and that reward signal, that score, teaches the language model to get better and better and better with every single attempt. And this is what I find so cool. The AI actually starts developing its own creative strategies. It learns on its own to break down complex ideas into simpler shapes. And get this, it even adds little contextual details that you didn't ask for, like sprinkles on a cake, just to make the whole scene make more sense. It's literally learning to think like a designer.
So our apprentice is shaping up. It's a better collaborator, and it's now a more precise designer. But there's one last huge problem. It's leaving all the lights on. Seriously, the energy cost of running these giant models is a massive, massive challenge.
Right, and a paper from Jihan Yu and their team called VoltanaLLM found something really fascinating and kind of counterintuitive. You'd think that running a GPU faster always uses more energy, period. But their research shows this U-shaped curve. Running a GPU at max speed is a huge power hog, for sure. But running it too slow means tasks take so long that the total energy used also goes up. The real sweet spot is right there in the middle.
Wait, hold on. So you're saying running a GPU a little bit slower can actually save a lot of energy without a huge hit to performance? That seems wild. How could that possibly work in a live system where demand is all over the place?
That's the million-dollar question. And the key is a new system design they call prefill decode disaggregation. The best analogy is a restaurant kitchen. They have one station for all the complex prep work and another for the quick final assembly. It's the same idea here. The heavy-duty work of understanding the prompt is split from the much faster job of generating the answer. This lets you use different tools and different amounts of energy for each phase.
Ah, okay, I get it now. And VoltanaLLM uses a two-part system to manage all of this. First, there's EcoFreak, which is like a smart cruise control, constantly adjusting the GPU speed to stay in that energy sweet spot while still hitting its performance goals. Then there's EcoRoute, which acts like a traffic controller, smartly sending new requests to the best available GPU to keep everything flowing smoothly.
And the result of all this smart management is just staggering. Their system can save up to 36.3% on GPU energy without sacrificing performance. Now, in a world where data centers can consume as much electricity as entire countries, a saving like that isn't just a small tweak. It's a massive leap toward making powerful AI both environmentally and economically sustainable.
So let's just pull this all together for a second. When you look at these three pieces of research, you see this really clear theme emerging. We are actively teaching our brilliant but kind of clumsy apprentice some very important new skills.
Exactly. We've taught it to collaborate through a real dialogue. We've taught it to achieve precision by thinking in code, not just pixels. And we've taught it to be efficient by intelligently managing its own power. Every one of these steps moves AI away from being this blunt instrument and toward being a true creative and analytical partner.
It really shows that the future of AI isn't just about more and more raw power. It's about control, it's about reliability, and it's about sustainability. That's what's going to unlock the really amazing applications we've all been waiting for.
Which really just leaves us with one final thought to chew on. What new possibilities open up when our AI partner is not just brilliant, but also truly dependable? Thanks so much for joining us on The Explainer.
Thanks, everyone. See you next time.